All right, so what might be a little foggy or hazy or just don't quite understand up to this point? Well, when we look at what we've talked about so far, Bohr models, electron configurations, naming compounds, adding together atomic masses. Up to this point, do you need to see any of this information again or would like to go over it again before we proceed? Okay, so if you were a guessing person, like for instance, when maybe you're looking at brackets to where you're seated in the conference, well, I'm guessing we will play this team. Well, that's what we mean by guessing. What do you suppose we would talk about next if you're telling me you're ready to proceed forward? What would probably or possibly be next? It was probably where some of you may, I'm not saying struggled, but had problems with this. Yes, what? What about it? You want to see that again? Okay. Trust me, you're not the only one, I'm sure, because some people just choose not to um, raise their hand. Now, possibly be on. Okay, so proceeding forward. What you can do then is, let's see here. Again, you can utilize this to make certain predictions on, actually this table's a little better, it's a little bigger, is on what it is for a Bohr model. Were you pointing at Bohr models or was it a linear depiction like this or does it have the semicircles? Okay, so that's a Bohr model. So you can make certain predictions upon how many rings there should be and how many are actually in that energy level. So 49 to 53, pick a number. a P block, you can make certain predictions on what you should see. So, if that is the case, which it is, how many energy levels should there be? I mean, where does antimony fall? Which period? The fifth one, correct? Okay. So, how many electrons are in the outer energy level for antimony? Now, that's the S and P put together, and you said, what? 5, that's correct. 2 for the S, 3 for the P block. That's where those 5 come from. Okay, so we've got 51 of these protons in the nucleus. Okay, so 1s2. Following your slide rule, that's what it's meant to use. Okay, then what? And each and every one of these is going to be a general pattern that follows over and over and over and over again. That's why it's called the periodic table. Okay, then what? And then the slide rule tells you what to do next. Okay? Then from 4s2 down to what? 3d10. Then back up to 4 what? 4p6. And at any time you can always stop and add together these numbers, because what's out here should equal what's inside of there. Okay? So after 4p6, what comes next? Four p6, what's after that? Okay? Then back down to what? Okay? Now, I'm willing to bet that if we stopped there, we would be at, what, 48 maybe? Well, let's double check. Okay? So here's 10, these 3. So 18, and 18. So 36, 46, 48. Right? Do we agree? Okay. So how many more should there be? There should be 3 more. Remember, some of them predictions you said that you could utilize. You correctly said antimony is in which period? The 5th. Well, how many of these do we have? 5. Okay. What column is antimony in? It's in the 5th column, okay? But with the P block only, what column is antimony in? 3. So that's where that comes from. 3 for the P block, but 5 for that energy level. Now when you add these 5 in there, that gives us our 51. Okay? So again, this is a pattern that repeats itself over and over and over again. Okay. Are we good? Are we tracking? For those of you who go join the Air Force or the Army or the Marines, I don't know about the Marines, but maybe the Army, they're going to say, are you tracking? That's what the drill sergeants will say. That means, do you follow? The military is in our future. Yes. No? The military is in your future. Some of you are shaking your head no. And just out of curiosity, why might that be? You just believe it's not for you? And that's the most logical answer. Okay? Or you just, maybe you think you might not be able to handle it. Actually, the physical aspect is probably the easiest. It's the emotional and mental aspect that people struggle with. So you just can't handle it up here. Yes? Okay, we'll address that later. Okay? All right, before I forget, we had this up here yesterday. Just something slightly wrong with that. We couldn't get it figured out. This is why. Because there's another hydrogen on there. Okay? because you correctly said, I just want to address this, there should be a double bond, okay? So there's one oxygen, okay? So 2 for that carbon, okay? Well, here's 3 for that carbon with another oxygen. So how many are around that oxygen? 7. It needs how many more? 1. So that is true, but what is the problem with this so far? Okay, the carbon only has 3 so far. It needs 4 for the dots. Now it's got 4, 6, 7. It's still 1 short, but what we didn't have up here yesterday was that last hydrogen. There we go. Now we got it. Okay. Just wanted to address that real quickly. All right. And from the organic portion, what was that called? COOH with an extra hydrogen. It's an acid in 1 carbon in length. Methanoic acid, that's right. Okay, so moving forward, can we proceed? Okay. All right, so going back to the first question we asked, what do you think would be next that we would work on? Someone said it. Balancing chemical reactions. How many of you think that, yes, I did struggle with that? Just 3, 4, 5? Okay. So with that, okay. Okay, so what can you tell me about that reaction so far? And what does SR mean? So even if you were not told that this was a single replacement reaction, how would you know that this is a single replacement? Because you have what here? A single lone metal, okay? So there would be 4 blanks over here for your coefficients. Okay, so what is sodium? What's the symbol for sodium? What's the symbol for magnesium? The chloride ion. Go by your negative ions. Chloride has a charge of what? -1. Magnesium has a charge of what? So since those don't add up to 0, what do you need to do? Okay? So you people are correctly saying 2 chlorides. Does anyone not understand why you need a 2 there? No. That's if it's by itself. You are correct. But remember, the answer that you get from the least common multiple tells you what to put below. And for some of you who understand this, it's probably about the 10th time that you have heard that, right? So hopefully by now it's somewhat set in. Now, you may have forgot, but now we've just reminded you again. And we did this yesterday then as well. Okay, so in a single replacement reaction, what is possibly going to happen here? This is going to get broken apart. Okay? Where does this break apart at? Between the positive and negative ions. Okay? So, we can go ahead and write magnesium here. Now, will that magnesium bond with sodium? No. It can't. Why can't it do that? You cannot put two positive ions together. Okay? So, well, you can, as long as you have another negative ion to bond to it. But anyway, magnesium plus what's left over. So if this broke apart, the sodium, right, your positive ions first, and then what's that bonding to? Okay, the charges will not change. What's the charge of sodium though? So what's significant about that adding up to 0? Yeah, you don't have to change that at all. So as of right now, we've got 1, 1, 1, 1. But it's not a balanced reaction right now. Okay? So the next thing you would want to do, write down your elements if you feel you need to. We got some magnesium, some sodium, and some chlorine. 1 to 1, 1 to 1, and 2 to 1. Does that look correct? Okay? Yeah. So if we got 2 chlorides on the left and only 1 on the right, what do we do? Well, why not just put this here and you're done? You're right. You can't do that, right? That's correct, because you're changing the chemical formula. Don't do that. Well, how about do we just put the coefficient here? No, you have to put it in front of the compound. So if we put a 2 here, and that gets distributed, how many sodiums do we have now? And chlorines 2. Okay, well, doesn't look like we're getting any closer, does it? But that's an easy fix, because sodium on the left-hand side is all by itself. So what would we put in front of here? So upon doing that, now you've got them balanced. So what do we put in these blanks over here? 2, 1, 1, 2. Okay? Are we good? All right. Otherwise, remember, you can always go back, see what you may have missed in the video. All right. What's another reaction that we talked about? Single replacement's one.
Double replacement, organic.
So double replacement, synthesis, now we're up to 3. There's 2 more. Combustion and decomposition. Okay? So which one would you like to see next? Combustion. Okay. So how do we know we have a combustion reaction? Because you have a hydrocarbon, okay? Really no surprise. Hydrogen and carbon, a hydrocarbon. Combining with what? And what's significant about the oxygen? It's diatomic because it's a gas, okay? Then what are your byproducts in a combustion reaction? No. Okay, I thought you said NO2. Okay. No, carbon dioxide and what? Is that it? And yeah, it's water. Okay. Now, this one is unlike any that you had seen during the time we had talked about that. This is why. Okay? Okay, so we've got our 4 carbons, and we only have how many hydrogens? Okay? Is that right? No, because that's how many hydrogens? That's two too many. So that must mean somewhere in here there is a what? There's a double bond. So where do you want it? 1 or 2? Okay? Now you've got the correct hydrogens in there. And what compound is that written in the red or whatever color this is? It's an alkene. That's your organic family. Okay, we're getting closer. Someone had said this. Okay, but we got to be a little more specific. Okay, so remember, here is your organic family. That tells you that somewhere in that carbon compound there is a what? There's a double bond. So what's this telling you? That there's 4 carbons. And what's that 2 telling you? It's telling you where that double bond is. All right. So this one is just a little more tricky. Okay? Because some of you may remember what we had said. If you have a combustion reaction and the hydrocarbon is even, that you would do what? You would take it times 2. But that's if it was an alkane. This is an alkene. So kind of doesn't want to play by the rules. So does anyone have this balanced yet? Did you double the 4? You're nodding your head no, and that's correct. You're correct when you're nodding your head no. Why not? Because you didn't need to. Yeah, that's the best answer. Okay? So should you, and how can you recognize that this is an alkene rather than an alkane? There's 2 less hydrogens, or you take the number of carbons times what? Times 2. This tells you it's an alkene. And one of the things that would happen is if you think, okay, this is an even number, I better double that right away. Well, if you do that, okay, so this is the wrong way to do it, okay? If you do that, what's 2 times 4? Okay. Then what's 2 times 8? So then you would put an 8 here. Okay. So as we look at that, what is, that's right so far, 8 times 2 plus 8 more, 24, well that does. But one of the things, they're all factors of one another. That's where the problem, I suppose you could say you could do this, but a better way of looking at that, oops, didn't mean to write that big. Okay, if we just leave that alone and go ahead and put a 4 over here, okay, well then we still have 8. We put a 4 here. 4 times 2 is 8, plus 4 more gives you 12. And notice that these are all factors of one another. Okay, how many of you think that was a low down dirty trick? Oh, good. Okay. So, moving forward, is any questions over a combustion reaction? The biggest thing to recognize, if you have a hydrocarbon and you get the same byproducts, carbon dioxide and water. Okay? So, what's another reaction you would like to see? Okay. So since we did this earlier, Someone give me a halogen. Why chlorine? Is that you just like chlorine? Okay. But you are right. That is a halogen. Okay? And we're saying this is a synthesis reaction. What does it mean to be a synthesis reaction? They combine. Okay? So that must mean this is a diatomic molecule, but now we're going to leave a little space here. Now it's an ion. Now it's chloride. Okay? So when we leave spaces behind metals, there's probably something that's going to go there. What might that be? Okay? So when we look at antimony, you can make a couple of choices. You tell me. You want a +3. That's fine. So then this is going to be called antimony 3 chloride. That's going to be important here in just a couple moments. Okay. So, we don't want that color. What is the symbol for antimony? Okay. What is the symbol for the chloride ion? Okay. Now be honest, how many of you may have forgot this? I'm not saying that you would, but may have. Well, that's pretty good, just 2 of you. Okay. All right. You do realize when you have the $100 seats that you can't see anything behind you. You do realize there's only one other person that raised their hand. No. All right. So now the charges will not change, but we didn't tell you what antimony was. That's why you got to look back at the compound. So while there's a 2 here, we must have to put a 2 there. Right? Why not? You're saying we don't have to. All right. We'll just leave it like that then. Okay. Must be getting closer, right? We said put a 3 there. You need to be a little more specific. Oh, well, I put them on the wrong side. Sorry. Okay. How about a subscript? Okay. So you don't think we need a 3 here?
No, not right now.
Okay. That's possibly a good way to look at it. Okay. So a little 3 here. So why did that little 3 have to go there? Because this is -1 and that's +3. Well, we didn't know this was +3 until we looked at the Roman numeral. So that's why you needed to have to know that. Okay. So the next thing, we can't balance out our antimony since they're already 1-to-1. But the least common multiple between 2 and 3 is what? So we had 3 there, 2 there, 1 and 1. Okay, so when you look at these come in pairs. These are odd. You need to get that up to an even number. So the only way to do that is to do what to this entire compound? Take it times 2 to change that to a 6. Then do what to this? Take it times 3. And then what about this? Okay, so 2, 3, 2. That's right. Okay, synthesis. There's your synthesis reaction. If you feel you need to go back and look at it, you can back to the science channel. Okay. So what's another reaction? we've got decomposition and double replacement. Which one do you want to look at next? Decomposition. Okay? Does anyone know what we mean by a mineral ore? O-R-E, not O-R, O-R-E. It is a chunk. So when we use your aluminum foil or your copper wiring or your iron for steel, you just don't mine that out of the ground and it's in a pure form. It's mixed with a whole bunch of other elements. That's what we call iron ore, copper ore, zinc ore, aluminum ore. So that means it's, when we say ore, O-R-E, it's combined with which gas? It's oxygen. It's locked up with it. So, copper, aluminum, or iron? Which one? Copper. Okay? Okay? We don't see it yet, but which copper? Why do you want to make it so easy on yourself? Okay. All right. So you want copper 1 or copper 2? Copper 2. Okay. So why would we say copper 2? Okay. All right. So what happens when something decomposes? Okay. Over here. Okay. So to balance that out, you got 2 oxygens on the right and only 1 over here. Okay. How about that? 2, 2, 1. Agreed? All right. I guess we don't need to erase that. So we did a single replacement first. Then we showed you a combustion reaction. Okay? Then we showed you a synthesis reaction. We just finished the decomposition one. There's only 1 left. That's a double replacement. Okay? So okay, so what would be an indication that that is a double replacement reaction? Because you have 2 distinct compounds. You don't have just a compound being broken up into its parts. Or you don't have a lone metal in a single replacement reaction. That's how we know this is a double replacement. Okay. So, nickel. I know, it says it right there. What's the symbol for nickel? And I don't, should we continue? Yes, no? No? Oh, okay. But we heard someone say no. So either you are all right and the one person's all wrong, or the one person's all right and the rest of you are wrong. Okay. All right. So, what's the symbol for nickel? What's nitrate? Go by your negative ions. Charge of nitrate's a -1, I heard. What's the charge of this nickel? Those don't add up to 0. 2 nitrates. Okay. Plus, what's potassium? What's sulfate? Okay. What's the charge of sulfate? Negative. Charge of potassium. Okay, that does not add up to 0. Okay, again, least common multiple is 2. The answer you get, you put below. Now we can continue. Okay, so we've got 1, 2, 3, 4 subscripts. So of those 4, are all 4 of those subscripts going to the right side for sure? 2 of them for sure? So which 2 for sure have to go to the right side? So this 3 on the NO3. Okay, why not this 2? Why not this 2? Remember, these were just used to balance out the compound. This 3 and that 4 are part of the formula. So that's why they have to go over there. Okay, so where does nickel and nitrate split apart? Okay, so nickel will bond with what on this side? Okay, so that's what? SO4? The charges have not changed. So is that's balanced, the compound is. Then what do we have left over?
Potassium nitrate.
So it's what? K, NO3. The charges do not change. Do we have to do anything? Okay? So is this something you can visualize in your head, or do you need to write them out? Visualize, okay? So the nickels are balanced. The potassiums are not balanced. Neither are the nitrates. Okay? So if we put a 2 in front of here, that does it. Okay. 1, 1, 1, 2. All right. There's only one portion left that we need to review. That is organic compounds. We did a little bit of that today. All right. So one of the things to keep in mind when it comes to semester exams, you're new to this, okay? It's one of those aspects that, for the most part, the semester exam will probably determine what your grade is now. Usually keeps it probably right where it's at. Okay? Can it cause you to go down? Yes. Can it bring your grade up? It can, not a lot. Don't bank on this. Some of you may be in here again next spring. Okay? That was a personal choice that some of you made a long time ago. All right, we'll catch up with you tomorrow.